Hi, let's begin chapter 14, which is on wave motion. Wave is different from particles having mass in that they can be located in the same place, right? At the same time, simultaneously. And if the two waves are located in the same place, unlike particles, they can interfere. That means the resultant waveform is combined. The resultant waveform is constructive interference here. And then if their phase is 180-degree difference, the resultant waveform is 0, which is destructive interference. And also, in between is possible. Phase difference doesn't have to be 0 or pi. These two are extreme case. But in between, any form of interference pattern can appear. And this is something in between. So if the frequency between the two waves have slightly different, if their frequency omega 1 and omega 2 are slightly different here by just delta, very small value, and as a function of time this oscillates at the same place, but at some point they constructive interference, the other time they can destructive interference. And so overall, conceptually, we can understand that there will be this oscillation having large period and also small oscillations. Wave can reflect because energy should be conserved. Right? For one-dimensional wave along string, wave should be reflected since if there is no energy dissipation. For a clamped hand, due to Newton's third law, because the string will act force on the wall, upward force, so the action is upward force from the string to the wall. So reaction from the wall to the string, reaction force should be downward. That's why the reflected wave has out of phase. If a wave exists in this space, for example, if the both ends are clamped, then this kind of wave can be fit into this space because of the reflected wave and incoming and reflected wave interfere each other. Now, Doppler effect. It applies to, for example, light waves and water wave and any waves. And depending on the relative motion of the observer and the source of the wave, wavelength frequency can change. Okay, that's the Doppler. What happens? When the source approaches the observer at some speed u, okay, then the source moves additional distance during every period t, additional distance ut through the medium between the wave crest, between the highest amplitude of the wave crest. So between these 2 points, it takes period t, right? During this period, the source will move, approaches by this distance ut. Lambda, which is spatial period, is now different from original lambda. Original lambda is a spatial period when source is not moving, but source moves and decrease now when source approaches the observer. The distance between the wave crest, which is lambda, is now decreased. This distance is now decreased by ut because source moved additional distance ut. So lambda prime, now new wavelength, is decreased wavelength, is lambda minus original wavelength minus ut. And what is t? Frequency has also changed because lambda f is v. So the frequency is now new frequency is v over lambda prime, which is increased. So for approaching source, we hear the sound pitch is increased, higher pitch. For in a similar way, if the source moves away from the observer, then what happens? Moving away source, pitch will decrease. So it goes down. Pitch goes down. Change. And this is also some additional stuff I want to introduce for in the wave chapter. There are 2 ways to cancel noise, which is one is isolation here. Isolation is basically you block the wave coming into your ear, for example, here. So I'm using earplug, and you just make all the waves reflected, not go into your ear. This isolation, blocking the noise. The other one is by using this kind of active noise cancelling headphone. What it does is for any incoming noise, this kind of headphone generates a wave which has opposite phase, out of phase. Waves having out of phase, so the resultant waveform is this completely destructive wave. That's noise cancelling, active noise cancelling. How do this kind of equipment can analyze the noise signal to know, the waveform, to generate some wave having 180 degree, different phase? We learned simple harmonic wave, which is the simplest form of wave. Wave is different from oscillation in that the disturbance travels along space, not only just oscillate in localized space as a function of time. It oscillates as a function of time, but also oscillate as a function of space. And the period of the space we call the wavelength. And there are two kinds of waves we can categorize: longitudinal wave and transverse wave, depending on the wave motion direction with respect to the propagation direction. If it's parallel, it's longitudinal wave. If they're perpendicular to each other, it's transverse wave. Water wave is in between, mixed of longitudinal and transverse wave. We learned also string wave, property of string. For example, power transmitted by this one-dimensional wave, and also string wave velocity, right, which is dependent on the density of the string, mass density of the string, and also tension of the string. And learn something about three-dimensional wave, basically sound waves. Also learn standing wave and some etc. conceptual stuff. There are many stuff squeezed in this chapter. Wave mechanics. Sometimes one complete book describe the wave mechanics. So a lot of stuff are packed into this chapter. But the most important part in this chapter is you should be able to understand the simple harmonic wave and the Doppler effect, how the frequency and the lambda changes with moving source and moving observer. So this chapter can be a little bit complicated and include many stuff compared to the previous chapters.